What are proportional relationships and slope? So this seems like an easy, straightforward question to answer, just defining some terms, right? Well, it's a little more complicated because once we get into the first one, we add more vocabulary we have to figure out and unpack. So a proportional relationship is when you have the slope is the same as the unit rate, and that's the same as the constant of proportionality. So we're looking at slope, unit rate, and constant of proportionality, which in a lot of these situations are going to be the same in terms of what we're looking at for examples. So we're going to be giving you proportional relationships that we have to work with and analyze. How do we figure these things out? Well, our unit rate is generally the coordinate 1 comma r, where r is the rate. So in this situation, I go over 1, and then I go up, and I get 2, 1, or 1 comma 2. Oops, I reversed all of these. Silly Mr. Donnelly making a mistake. All right. So anyways, because I was thinking y over x. So this is 1 comma 2, 2 comma 4, and 3 comma 6. All right, so 1 comma 2, which means r is equal to 2. That's how we figure out unit rate. What is the y coordinate when the x coordinate is 1? Constant of proportionality is k, and that's y divided by x for any coordinate within the graph here. So if I take 4, 2, and I do 4 divided by 2, I get 2. 6 divided by 3 would be 2. 2 divided by 1 would be 2. So anything that's going to be 2 is your constant proportionality. Slope. This is probably the most important one that we're going to continue to use even as we move beyond proportional relationships. Slope is rise over run. Rise over run. Right? So you got to stand before you can walk. And so you always put the y coordinate, which is your vertical coordinate, over your x, which is why I wrote these backwards, because I was thinking this. So I was thinking y first, because that goes on top. So in this case, say I go from down here 1, 2 to 3, 6. In order to do that, I have to go up 4 over 2. So the change in y from 6 to 2 is 4. And the change in x from 3 to 1 is 2. So 4 over 2. Or it's the same thing as if I were to go down here and just go to this coordinate, and I have to go over 1 up 2. So my change in x is from 2 to 1. So my run is 1, and my rise is 2. 2 over 1. 4 over 2 and 2 over 1 both are equivalent to 2. In this case, we have a proportional relationship represented on the graph with a unit rate of 2, constant of proportionality of 2, and a slope of 2. Slope, when we're dealing with proportional relationships, slope is going to be the term that I personally use the most. It's most relevant kind of leading into other things. Now here's a situation that you'll have where we have to compare proportional relationships to make decisions. In this case, we're looking at Jacoby and Amelia, and we're looking at how much they get paid. Amelia, we have a graph. Jacoby, we have a chart. In Jacoby's chart, he has hours, which are x, and money. And Amelia's money here is on the y coordinate, and hours are on the x. And we're just looking at how much they get paid. I've already done some of the work here. Hours goes from 5 to 8, which is 8 minus 5 is my change in x. And money is from 45 to 72, so my change in y is 72 minus 45. That equals 72 minus 45 equals 27. 8 minus 5 equals 3, so 27 over 3, or 27 divided by 3, equals 9. So Jacoby makes $9 per hour that he works. That's his unit rate. That is, in 1 hour, he makes $9. That'd be his unit rate. That's the slope if this were a line. Amelia's, I have 2 coordinates drawn here. One is at 4 hours, she makes $32. And at 8 hours, she makes 64. So if I do my rise over run, it goes up 32, or 64 minus 32, and it goes over 4. So 32 divided by 4 equals 8. Amelia only makes $8 an hour. So we could say Amelia's job doesn't pay as well as Jacoby's, and then we could use that to make various decisions, or we could determine who would be able to reach a certain goal at a certain point. All right. Another situation you might have is you might have to just interpret this graph. This graph shows you the cost of apples measured in pounds. And so I might say, like, what does this slope tell me? Well, the first thing you'd want to do is you'd want to find an easy coordinate. And I found in this one that at $6, it gives me 5 pounds of apples. You might want to use a calculator then to do 6/5. What would that equal? It equals 1.2, which would mean $1.20 per pound. That's your slope. What you might run into with these types of problems too is you might see other lines on the graph. You might see, okay, so this is the pounds, and let's say instead of apples, it's just pounds of fruit. LBS of fruit. And then each color is a different fruit. So maybe I have this line up here, and we'll draw a purple line down here. And so you'll say, what do these lines tell you about the cost of these fruit? Well, the red fruit has a steeper slope. So because the slope is steeper and it kind of rises faster, think about it, for 1 pound, it's going to cost more. But the purple line is less than the cost of apples, so that for 1 pound is going to cost less. Let's say red is watermelon, purple is plums. So the watermelon has a steeper slope and will therefore cost more than the apples. And the plums, the purple slope, the slope is not as steep, so it'll cost less than the apples. And that's a comparison that you might need to make. Again, what we're talking about here is what are proportional relationships and slope, and just kind of how to navigate and work around this.